In this presentation, we will learn how to add two numbers with the help of singly linked list. This is part 1 of addition of two numbers using linked list. So without any further delay, let's get started. Let's say we have these two numbers 3687 and 567. Our target is to simply add these two numbers. These are the representation of these two numbers. I simply put them over here 3687 and 567 for the purpose of addition. We know that the addition starts from the units place, so we will first add the digits of the units place. You can see that 7 plus 7 gives 14 and 4 must be placed over here and 1 will get carry forward, right? Now what is 8 plus 1? 8 plus 1 is 9 and 9 plus 6 is 15. So 5 must be placed over here and 1 will get carry forward. It's very simple, right? What is 6 plus 5? 6 plus 5 gives 11 and 11 plus 1 is 12. So 2 must be placed over here and 1 will get carry forward. Now what is 3 plus 1? 3 plus 1 is 4. So the result so obtained is 4254. This is the result of addition of these two numbers, that is 3687 and 567. It is very simple to add two numbers and we already know the procedure. But let me tell you that addition of two numbers with the help of singly linked lists is not that simple. Okay, it is not that straightforward. We will understand the process of addition of two numbers with the help of singly linked list in this particular presentation and in the subsequent presentations. By the end of this lecture and by the end of the subsequent lectures, you would be able to know it very easily that how to add two numbers with the help of singly linked lists. So without any further delay, let's get started. The procedure of adding two numbers using linked lists is divided into three parts. I have divided the whole process of addition of two numbers with the help of singly linked lists into three parts. The first part is obviously to represent an n-digit number using a singly linked list. This is quite a challenge because here we have to fetch each digit of the number and place them individually in all the nodes of the singly linked list. Here obviously if we want to represent an n-digit number, then n nodes of the singly linked list are required. Here obviously each node of the singly linked list is capable enough to hold one single digit of the number, right? Now the next step is to reverse the numbers for addition. This is also important. We already know in the process of addition, the digits at the units place will get added first. And obviously if we try to represent an n-digit number using a singly linked list, then the last digit of the particular number will get stored in the last node of the singly linked list. In order to simplify the process of addition, we must reverse the linked list. This is very important so that we can start adding the numbers from the units place itself. Okay. Obviously, the last step is to add the numbers and store the result in the resultant singly linked list. Okay. So let's say we have two numbers 367 and 57. First, we will represent these two numbers 367 and 57 with the help of singly linked lists. And obviously 367 needs 3 nodes and 57 needs 2 nodes, right? 3 will be stored in the first node of the singly linked list, 6 will be stored in the second node of the singly linked list, and 7 will be stored in the third node of the singly linked list. Similarly, 5 will be stored in the first node of the singly linked list, 7 will be stored in the second node of the singly linked list. Now we have two different singly linked lists, right? And you can also see that the units place has the digits 7 and 7 in both the numbers, right? 367 and 57. In both these numbers, we have 7 in the units place. And we must add these two digits first. For this purpose, we will reverse the singly linked lists, right? And this is the second step. And after this, we can simply add the numbers and addition of numbers becomes simple. And then after this, we can store the result in the resultant singly linked list. In this presentation, we will learn how to represent an n-digit number using a singly linked list. Let's say we have a 4-digit number, 3687. We simply want to represent this number with the help of singly linked list. We have a 4-digit number, 3687, and also we have a 3-digit number, 567. Okay. Our primary target is to represent these numbers using singly linked lists for further processing, right? This means we must have n nodes in the linked list for an n-digit number, where each node is capable of representing a single digit of the number. I've already told this that for every digit we must have a node, right? This means that if we want to represent an n-digit number, then we must have n nodes in the linked list. This is very important. Here each node is capable enough of representing a single digit of the number. For example, let's say we want to represent this particular number 3687 with the help of linked list. This can be represented with the help of the following linked list. This is how the linked list for this number looks like. Here obviously the first digit will be placed in the first node of the singly linked list. Second digit is placed in the second node of the singly linked list. Third digit is placed in the third node of the singly linked list. And the last digit of this particular number is placed at the last node of the singly linked list. Right? And here you can see this head1 pointer is pointing to the first node of the singly linked list. And now let's say we want to represent this number 567 with the help of linked list. And obviously you can see that this is a 3-digit number. Therefore 3 nodes are required in the singly linked list. This number is represented with the help of following singly linked list. This is how the singly linked list looks like. Here obviously the first node will store this value 5, second node will store this value 6, and third node will store this value 7. And here head2 pointer is currently pointing to the first node of this singly linked list. Now the challenge is to simply store the individual digits of the number in the linked list. For this purpose, we will apply a simple logic to get one digit at a time. User will enter a particular number. Our target is to get one digit at a time from a number and store them in the singly linked list. Here we will apply a simple logic to get one digit at a time. And that logic is divide the number by 10. This is the logic we will use for the purpose of getting one digit at a time from the number. Let's see how this works. For example, we can get the last digit of the number 567 by taking the mod of 5, 6, 7 and 10. Right? We can simply take the mod of 567 and 10. In this way, we'd be able to get the last digit of the number 567. Let's take the mod of 5, 6, 7 and 10. Obviously, this gives this value 7, right? Which is the last digit of this particular number, right? In this way, it is easy to get the last digit of the number. Now, what about the second last digit? In order to get the second last digit of the number 567, we will first divide the number by 10 and then take the mod of the resultant with 10. This means that we will first divide the number by 10 and then after this we will take the mod of the quotient and 10. So first we will divide 567 by 10. This will give us this quotient, that is 56. And then after this we can take the mod of 56 and 10. This will give us this value 6. Simple. After dividing 567 by 10, we'll get this value 56. And then we can take the mod of 56 and 10. This will give us the second last digit of this particular number, right? And how to get the third last digit of the number? In order to get the third last digit of the number 567, we will first divide the number by 10 and then take the mod of the resultant with 10, right? First we will divide the number by 10 and then take the mod of this number and 10, right? 56 divided by 10 will give this value 5 and 5 mod 10 is also 5. This is the third last digit of this number 567 or the first digit of this number. This process will continue until we will get 0 from the result of division. As you can see, 5 divided by 10 will give this value 0. After getting this value, we can stop our procedure. Okay, and that is it. This is the code for the purpose of creating the linked list. Here, first we will declare this variable n, which will store this value 567, right? Our target is to simply represent this number with the help of singly linked list. Here we have to store each digit of this number in the singly linked list. After this, you can see I have declared a head pointer and currently this pointer is holding null. And then we have this while loop. And here in this while loop, I am checking this condition, is n equal to 0? If n is equal to 0, we'll get outside of this while loop, right? Otherwise, we'll continue. You can see that n is not 0. So we'll continue. Now I will simply call this function add node. And to this function, I'm simply passing the head and n mod 10. Head will get replaced by null and n mod 10 will get replaced by 7, right? Because the mod of 567 is 7. This function will simply add the new node at the beginning of the linked list. This function is capable of adding the node at the beginning of the linked list. I just want that this function must add the new node at the beginning of the linked list. Okay. And then after this, it must also return the address of the first node of the linked list. And we will store that address within this head pointer. Let's just call this add node function. This is how this add node function looks like. You can see this. These are the parameters of this add node function. Obviously, this head pointer will receive null. And this val will receive this value, that is 7. And here with the help of this code, we'd be able to create a new node. And you can see this is the new node pointer, which is currently pointing to this particular node. And obviously this is the new node created so far. Here you can see that 7 will get stored. That is, this value will get stored over here. and obviously in the link part of this node we will store null, because this is the new node, right? And after this, we have this particular line of code, that is new node link equals to head. Now what is new node link? New node link is this part, right? We must replace this by the head. We know that head is containing null right now, so we'll simply store null over here. After this, head must point to the new node. And here you can see that this head pointer is now pointing to this node, because this is the first node of the singly linked list. After this, we'll simply return head back. And here this add node function will receive that head, and here this pointer will receive that address, and we can clearly replace this by the address 7000. After this, the n must be divided by 10, right? We must divide this number by 10. We'll get 56 after this operation, that is n equal to n divided by 10. And then we will check this condition, is n equal to 0? You can clearly see this, that n is not 0 right now, n is 56. Therefore, we can get inside this while loop and again call the add node function. And to this function, this time we will pass this address 7000, and obviously n mod 10 must be replaced by 6. This is how this whole procedure works. I hope you get the idea. Obviously, here we will pass 7000 and 6 to this add node function. And these values will get received by this head pointer and val. Head pointer will simply receive the address 7000, and val, this particular variable, will receive value 6. After this, we will create a new node. This is how the new node looks like. And obviously in this new node, we will store the value in the data part, that is 6. And in the link part, null will get stored. This is the process. We already know this process, right? After this, new node link must be updated by head. This means that the link part of this node must be updated by the head, which is nothing but 7000. Now this node is simply pointing to this node. This means that this node has been inserted in front of this node. After this, the head pointer must be updated so that it can point to this particular node. And this is how the linked list looks like, right? And after this, we can return head back. And here this add node function will receive that address. And obviously that address will get stored in this head pointer. So this 7000 address will now get replaced by 6000 address. And then after this, we can simply update the n value. That is, we will divide this number by 10. That is 56 by 10. It will leave this value 5, right? N divided by 10, that is 56 divided by 10, will give value 5. And now we can continue again. 5 is not equal to 0. So we'll call the add node function, and this time we'll pass 6000 and 5 to this function. Now val has received this value 5, and obviously head pointer has received this value 6000, right? Which is the address of this first node, right? After this, new node is created. Here you can see this is how new node is created, and you can see that data part is holding this value 5 and link part is holding null. Then after this, we have to update the link part of this node so that it can point to the first node of this particular linked list, because we want to add this particular node in front of this linked list, right? That is why we must update the link part of this node by head. Head is currently holding this address 6000. So we will replace this null by 6000. And that is what is going on here. After this, the head pointer must be updated so that it can point to this particular node. And now this becomes the first node of this linked list, right? This is the resultant linked list. This is the actual number, right? 567. After this, we will simply return head back. And here this head pointer will receive that address, that is 5000. And now we will update our n variable. And now we'll divide this value by 10. This will give us this particular value 0, because 5 divided by 10 is 0, right? And after this, we'll check this condition. Is n equal to 0? Obviously n is now 0, so we'll get outside of this while loop. So this is the resultant linked list so obtained. That is, we have this linked list where head pointer is pointing to the first node of this list, and you can clearly see this, that this linked list is the representation of the number 567. Isn't that so? And finally, we will call print function for the purpose of printing all the elements of this particular linked list, right? And here is how this print function looks like. In this print function, obviously, this head pointer will receive the address 5000, which means that it will receive the complete linked list, right? After this temp pointer is created, which will simply point the first node of this linked list. This particular pointer is required for the purpose of traversal. Now here we will check this condition. Is head equal to null? Obviously, head is not equal to null. If head is equal to null, then there is no such number. Otherwise, we'll continue. Here we'll go to this else part, and in this else part you can see we have this while loop, and here I'm checking this condition is temp link equal to null. You can see that temp link is not null, so we'll continue and we'll simply print this message on the screen. That is %d and then this arrow. Let me tell you, this %d will get replaced by temp data at the time of execution, right? Obviously this is the placeholder for temp data. What is temp data? Temp data is 5. So here this %d will get replaced by 5. And after this we'll place this arrow. And then after this we will simply update our temp pointer so that it can point to the second node of this linked list. And again we'll check this condition is temp link equal to null. Obviously temp link is not null. So we'll get inside and we'll simply print this message again. Now this time temp data is 6. So 6 will get printed, and then after this arrow will get printed, right? And then we will again increment our temp pointer so that it can point to the last node of the linked list. And now we will again check this condition is temp link equal to null. Temp link is equal to null, right? This means that we'll get outside of this while loop and simply print the value 7. Now you can clearly understand that why I have put this condition temp link not equal to null. Because I want that my pointer should stop at the last node, and this is important because I just want to print this value and I don't want to print arrow after this value. You can see this in this printf function. Every value is followed by this arrow. So value will get printed and then arrow will get printed every time, right? This is just one way of telling that this is nothing but a linked list. And I don't want this for the last element of this linked list. I just want to print this element on the screen. And I don't want to print this arrow after this particular element. That is why I have put this condition temp link should not be equal to null, so that I'll stop my pointer at the last node, and then after this I would be able to simply print this particular element on the screen. And this is how the output looks like 5, 6, 7. Now let me just show the complete code in code blocks. This is how the complete code looks like. Here we have a struct node, we have add node function, we have create ll function which will create the linked list. And here you can see we have this print function also, right? And after this obviously the main function is there and execution starts from the main function. First I will ask the user to enter the two numbers. User will enter the two numbers and I'll simply store those numbers within these two variables a and b. And after this I'll simply print this message linked list representation of first number is nothing but this. First I will call this create ll function. This will create the linked list, and then I'll call the print function, right? And then I'll print this message linked list representation of second number, and I'll simply print the linked list representation of the second number on the screen, right? This is how it works. We already know how create ll function works and how print function works, right? Let me just execute this code. It is asking us to enter the two numbers. Let's say I enter 567 and 3698. You can see this is the linked list representation of the first number, and this is the linked list representation of the second number, right? That's it. Okay friends, this is it for now. Thank you for watching this presentation.